Welcome to the third module of our data microcredential course. Let's begin the data preparation journey by first understanding data types and formats. By now, you have just read about Aisha and the challenge she's facing at Help Life cleaning messy flood tender data for an important district collectors meeting. But before we dive into Aisha's dataset, let me ask, have you ever tried to calculate a total in a spreadsheet and gotten an error message instead of a number? Or sorted a column of dates only to find April appearing before January, right? These problems happen because of a subtle but critical confusion, mixing up data types with data formats. In this video, you will learn the difference between what data fundamentally is versus how it is written, and why that distinction makes or breaks your analysis. We will explore these concepts using the real dataset Aisha is working with. 59 flood preparedness tenders from Orissa. Let's dive in. Before we explore data types, let me quickly introduce this dataset. This file contains 59 flood preparedness tenders from Odisha, collected from government public procurement records between 2021 and 2023. Each row represents one tender, a contract for flood-related work like building embankments or repairing drainage systems. You will see columns for tender amounts, dates, districts, and work descriptions. Aisha needs to clean this data so it's ready for analysis. But that starts with understanding data types and formats. Here's the key distinction. Data type tells us what the value fundamentally is: a number, text, a date, or a category. Data format tells us how the value is displayed, whether it has currency symbols, how dates are written, or whether text has extra spaces. Think of it this way. Your name is text, that's the type. Whether you write it in uppercase, lowercase, or with extra spaces, that's the format. The type determines what operations you can perform. The format determines whether these operations will work correctly. Let's see this in action using Aisha's dataset. Let's start with text, also called strings. Text is great for labels like district names, department names, or work descriptions. But text can get messy fast. Look at this column called tender category. It should contain simple categories like works or services. But watch what happens when I scroll through the data. Notice the inconsistencies. Some entries say works in all caps. Another says work without the S. This one says work with a space in the middle. And this entry has spaces before and after WOR. These are all text, but the different formats will cause problems when we try to count or filter them. Now let's look at another text column with similar problems. Tender type. This should tell us whether the tender was an open tender or a national competitive bid. But again, formatting chaos. We have open tender in lowercase, open tender with no space, open tender with extra spaces, and mixed case, and open tender with random capitalization. Same information, same type, text, but 5 different formats. If I try to filter for all open tender entries, I will miss most of them because of these formatting differences. This is why format matters just as much as type. Next, let's talk about numbers. Numbers are quantitative. You can add them, calculate averages, find totals. Look at the awarded value column. This shows how much money was awarded for each tender in rupees. These are stored as numbers, which is correct. But here's a critical distinction. The tender underscore district column has a problem. Most entries show district names like Angul or Khorda. These are text, which is appropriate. But look at this entry. It shows the number 123 instead of a district name. And this one shows question mark, which are special characters. These inconsistencies mean the column contains mixed data types, which will break our analysis. Dates are another critical type. Computers need dates in consistent format to sort them chronologically and calculate time differences. Look at the published date and contract date columns in Aisha's dataset. Fortunately, these are stored in proper date format, year, month, day with timestamps. This ISO format, 2021-01-19, sorts correctly and avoids confusion. But imagine if some dates were written as 1901-2021 and others as 01-19-2021. You have chaos. January could be confused with the 19th month and sorting would put April before January. The takeaway? Dates must be stored in standardized format, preferably YYYMMDD. Before we wrap up, let me briefly mention scales of measurement. This is how we classify data based on what mathematical operations make sense. There are three main scales. Nominal data, which is just categories with no inherent order, like district names. You can count them, but not rank them. Ordinal data, which has categories with a meaningful order, like low, medium, high. Or tender status rankings. You can rank them, but not calculate averages. And then numeric data, which consists of actual numbers where mathematical operations make sense, like tender amounts or project duration in weeks. Understanding these scales helps you choose the right analysis method. For more depth on this concept, check the readings linked in this unit. So, what have we learned? Data type, whether something is text, number, date, or category, determines what operations are possible. Data format, how that value is written, determines whether your operations will actually work. In Aisha's Odisha's dataset, we saw text columns with inconsistent spacing and capitalization, a district column mixing text and numbers, and the importance of standardized date formats. When types and formats are messy, your calculations fail, your filters miss data, and your charts lie. The good news, these are fixable, and you will learn exactly how in this module.